All right, good day again. So here we go again on simplifying statistics with Microsoft Excel. Okay, so this is our topic for today: the test for hypothesis and the type of errors. Okay, so this is very common on most of the research. Okay, so we'll go straight ahead and then compute for the z value here. And then we will explain later the underlying formulas on the right side. Okay, so we'll go straight ahead. So we have a population mean here of 2,400, and we have a sample mean of 2,460. Okay, and we have a sample which is denoted as n, 50, and a standard deviation of 200. Okay, this is a sample standard deviation. Okay, so it says here, this is sample from the book. Okay, so uh, the null hypothesis says that the mean is equal or lesser than 2, 4. Okay, and the alternative hypothesis is that the mean is greater than 2, 4. Okay, 5 does not meet specifications, and 5 meets specifications if it's more than the mean. Okay, so we will compute that. Okay, so to get the z value, we will be using this formula here. Okay, what we're gonna do is um, the sample mean minus the population mean, okay, over uh, the standard deviation, sample standard deviation, over square root of the sample, okay, sample population. Okay, okay, I think we need to put this one in. Okay, there. So the answer, the z value, okay, let's get the z value. Z value is 2.12. Okay, so we're gonna use here we either gonna use here the 0.10 or the 1.645 or the 1.96.05. Okay, from the book, they use the 1.645. Okay, 1 point, okay, 1.645. Okay, so since the z value is greater than this one, okay, it means that we will reject the null hypothesis. Okay, the um, the we just have to put some alpha here of 90%, 95%. Okay, so the 95% is 1.635 and 1.964. Okay, 1.96 and 1.645. Okay, so it's just saying here that um, the null hypothesis says that the mean is equals to 4. Okay, so based on this assumption here, since the the answer is 2.12, but it's more than the z value of 1.96 and 1.65. Okay, um, we will reject the null hypothesis and we say that the pipe meets specification. Okay, what if we lessen this one to 2450? Okay, so using both 1.65 and 1.96, we will accept the null hypothesis. Okay, so we will accept the null hypothesis that um, the pipe, if the answer is 1.77, pipe is acceptable. Pipe is um, does not pipe does not meet specifications. Okay, and okay, so at this is at 95% level. Okay, so we will say here at 95%. Ah, okay. At one point, yeah, at 195% confidence level, the pipe does not meet specifications. But at 90% confidence, okay, at 90% confidence level, the pipe meets specification. Okay, so since the book uses the 90%, but here, since I love using 95% confidence because it's very common and it's been used a lot by a lot of researchers, then we will follow this one. If the sample mean is 2,450, we can decide that at 95% confidence level, pipe does not meet specifications. Okay, so what if we will change this one? So the answer now is 2.12. So uh, our decision will we will decide that at 95% confidence level, the pipe does meet uh, specifications. Okay, so that's how to check. Okay, and given also that the before doing this one, you must make sure that the sample the sample population is normal. Okay, so since we've already discussed how to uh, do some hypothesis. Okay, let's discuss this one. Okay, this is from the book. Okay, so this computation here is 2,4 is the U. Okay, um, this is the population mean. Okay, so this is the it's part of the parameter. Okay, so the X here is the sample population, and this is the actually the 2,4 here is the parameter for a certain manufacturing of pipes. Okay, population mean. Okay, the desired population mean. Okay, and the S here is the standard deviation. Okay, so it's here, and the N here is the 50. Okay, and also here, we can see here this is the mound shape. Okay, this is the distribution for 1.645. Okay, and anything that goes 1.645 we will reject. Okay, that is also what happens here. Okay, so by using 2460, since 2.12 is greater than 1.96, we will reject. And by rejecting that, we will decide that the pipe meets specification because U is more than the mean is greater than 2.4. Okay, so here, if it falls under here, then we will accept. If it falls here, then we will reject. Okay, so I already have discussed this one. So let's discuss this one. Okay, so for here, this is the type of the error. Okay, so if we accept, okay, a a hypothesis, the null hypothesis, if we accept this one, let's put it here. If we accept this one and the um, and the answer is true, okay, that's a correct decision. Okay, and if we accept but it has But the if we access the if we access the null hypothesis, but it is false, then we have a type 2 error. Okay, okay, and also the null hypothesis, which is true. Okay, uh, for example, we reject the null hypothesis of this. Let's say we'll use the 1.96. Okay, and we will reject this one, and we have used 2420.71. We rejected that one. Okay, um, since it's wrong because 1.96 is under the 0.71. Okay, you can see it in the bomb shape here. 0.96 is under around this one here. Okay, or even in using 90%, let's just use 90% because we use the mound shape here of 90%. Okay, so we have to delete this one. Okay, even this one, okay, under 1.7, 1.645 here. Okay, 1.645. Okay, 1.71 is under here, so we will have to accept, but you rejected it. So that's a type 1 error. Okay, and if you reject it, then it's a correct decision. Okay, I hope you have learned. I hope you have understand that one. Okay, and if you have questions, you can just post your comments down the video. Okay, I'll be happy to answer that. Okay, and I think I already have discussed um, all of the test of hypothesis and the type of errors. Okay, and I'll see you again in my next video. Thank you.